Oh, okay. So a tuna saw a marlin swimming at 1 meter per second. To get away from the marlin, the tuna swam 6.4 seconds. Yeah, at a steady speed. In that time, the tuna swam 9.6 meters. All right, so a tuna saw a marlin. So here's the tuna. Here's the marlin. And the marlin is swimming at 1 meter per second. And to get away from the marlin, the tuna swam for 6.4 seconds at a steady speed. All right, so 6.4 seconds at a steady speed. And that time, the tuna swam 9.6 meters. 9.6 meters. What was the tuna's speed? Okay. So this is a very basic distance equals rate times time problem. And you could, a kind of a good way to do them all actually is just to do like a distance equals rate times time box. Like this particular problem, you can just drop it right into this equation. So you could do like, all right, well, this guy, like if I want to know its speed, I want to know its rate, right? So divide both sides by t. And then you're going to get rate equals distance over time, which makes sense, right? Because like on the freeway, I drive 65 miles per hour. So it's distance over time. It will be always be speed. Okay, so all right, well my distance, that tuna did 9.6, is it, what is the unit? Oh, meters. And then it did it in 6.4 seconds. And then do you know what the answer is? If you had a calculator, what would you do? Yeah, so you divide the two and you're going to get 1.5 meters per second. But a better way to do it, I mean, this way is just totally fine for this problem, but for more difficult problems, you can do a box. So you go like that, and you have distance equals rate times time, because a lot of times you'll be comparing two things. Like somebody like walking to school and then riding a bike back or something like that, or like a boat and its current, and then you could start like, you know, making equations by like that plus that is that, or that plus that is that total distance, and like you can make equations from your box. So on the flashcards, you'll want to make a box like this. Okay.